Okay, we're live. We'll just give a minute for everyone to file in here. Okay, we're gonna get going here, Greg. Hello, everyone. Welcome to day 2 of Ranger Inspections Think Tanks 25 online conference. Thank you for joining us again today. This is a special year as we're proudly celebrating 25 years of business in 2025. My name is Alex Romano, and I'm the Director of Operations in Canada and the United States at Ranger Inspection. Please remember to put your questions in the Q&A chat box. They can be viewed by the moderators backstage and will be answered at the end of the session. Our last speaker for today is our very own Greg Mann, the Director of Advanced Services at Ranger Inspection. He's the king of special teams, all things drones, 3D analysis, and volumetric strapping and calibrations. Today, he's presenting on leveraging new drone technologies for asset integrity. Greg, thank you very much for your time. Please go ahead.
Awesome. Thanks, Alex. Yeah, I mean, as Alex said, I director of event services here. I look after pretty much anything special that comes across, but mostly drones, 3D, volumetric calibration, my day to day. And then, yeah, like, I mean, I've built some robots to go down some pipes on in bolts on the highways, stuff like that. So anything to keep me interested and keep me going. So if you got any special projects, just send them my way. Okay, so uh, I know a lot of you have seen me present on drones before. There will be a little bit of overlap with some of the previous ones just because we have new people with us. So I am going to cover some of the basics, but then we're just going to go into the cool new things that I've been doing over the last kind of year or two, and uh, all the new technology, the stuff that gets me going. So it is called leveraging new drone technologies for asset integrity, but it's really just kind of cool things that I think are going to be helpful for everybody and increase inspection effectiveness. So what is drone inspection? Drone inspection is depending on the payload, you can do everything from UT, video, infrared, LiDAR, photogrammetry, you name it. But the main things we're going to look at today is inspection of tanks, vessels, piping, tower stacks. I've got silos we're going to look at. I've got an ice inspection we're going to look at too. That was very recent from last month with the freeze out east. So we're going to look at that as well. The things you can get is, you want to inspection of the wells, corrosion, coatings, rafters, supports. You can get this drone and a lot of drones into areas that you can't get into very easily with humans. You might need a crane, you might need rope access, AWP, that sort of thing. Whereas with a drone, we can kind of buzz up, have a good look at it, see if we need to do any further investigation. The benefits. So reduce risk to personnel. We can look at areas that we may not have to send somebody into, or we can look at area like higher risk areas and just see if we need to actually send someone in there to have a look. So we can send the drone in first. If we lose a drone, that's fine. If we lose a person, that's not fine. We never want to do that. So we'll happily sacrifice the drone over a person any day. So I kind of mentioned reduction in temporary structures. So not as much need for scaffolding and AWPs unless the drone picks up that you need further investigation. A lot of people think that, hey, we're going to send the drone up to this roof, have a look. We're not going to need to do anything because the drone's up there. The drone can only see what it can see. If there's scale buildup, if there's product buildup, the drone can't see through that. It doesn't have X-ray vision. It doesn't have a scraper on it. So it's not like I can just go up there, scrape off some scale and look underneath. You may still have to build that temporary structure. The nice part is with the mapping and modeling now is that, if you have 100-foot or 200-foot diameter tank, you now don't have to build that scaffold the whole way around. It may only be a small section that we need to look at. So, you save that time, save that money just going to where you're actually needed to perform the inspection. and that reduces downtime, mobile equipment, and everything is recorded on the drones. A lot of them are, foolproof. They're kid-proof for me. They just start recording as soon as I start it up. So, don't have to worry too much about not hitting record. The only thing you have to worry about is making sure that you have enough onboard memory. That's kind of it. Some more applications. So, talked a little bit about the towers, stacks, tanks, everything. We will touch a little bit on today, like a bit of environmental monitoring with some OGI cameras. That also gets into like the search and rescue using infrared, mapping and modeling, photogrammetry, 3D imaging and modeling. I mean, that's a little bit of a crossover for my other departments of 3D there. Site mapping and monitoring, survey, and of course, ultrasonic thickness measurements. I know somebody in Earl's session earlier today asked about that in the Q&A, so I'm going to cover that for you today as well. Another quick thing I do want to go over, Earl did cover it this morning a little bit too, but this is a frequently asked question for me, is there an intrinsically safe drone? The short answer is no. You can Google it, and a company has apparently had an intrinsically safe drone since 2016. It's ATEX certified out of Europe. I've never seen it. They've never come back to me. I've been trying for 8 years. So honestly, if it exists, they're sitting on $1 billion idea and not implementing it. So and in my opinion, I don't think you can get it anyway, just with the blades and everything. That's going to create too much static. So I don't think there'll ever be an intrinsically safe drone coming up. The next thing I want to touch on is, and frequently asked questions, is regulations. So regulations between Canada and the US, they're fairly similar. So for both sides of the border, to fly a drone for work, you do need, in Canada, your advanced drone license. In the US, you need your Part 107 license. If you're just flying for fun and your drone is under 249 grams, under 250 grams, or 249 grams, you can fly it for fun. You don't need to register it. It's only if you're going to take photos and then sell them, or if you can upload them to YouTube or anything like that. Any kind of money change of hands, you need these licenses. Otherwise, the fines are pretty big. To get your advanced license here in Canada, you do need to sit a couple tests and also do a flight review. For the Part 107 exam in the US, you have to go to a flight center and sit the exam in an actual test center. I have both the Canadian and the US. The nice part is recently it has been getting a lot easier to get approvals for areas of high risk. So around airports where you can you got tons of apps, you can look up how high you can go. And then around these airports, a lot of them are set at 0 meters, 0 feet. But you send in approval to FAA, send in your JSA, what you're going to do for safety, how you're going to map it out, what you're going to do in case something happens. And generally, the last one I did at an airport in Houston, it took roughly a week to get the approval back. That being said, it could have taken a bit longer, but they called in, we went through my inspection plan, my mitigations, and they gave me a approval there to do the inspection right at the airport. Like, fences here, I'm right here looking at some tanks that were actually going to fuel the airplane. So, all right. Now, what I want to do from here is we're going to go into some videos. From here, we're going to go through a series of videos. Then we'll pop back into the slideshow a bit later. So let me just get to the first set of videos. Okay, so here's an example of the internal drone. This is the Helios 3. As you can see, it's got a cage on it. It's got a 4K infrared camera on the front. You got LiDAR on the back. So you can do mapping and modeling of confined spaces. This is specifically designed for confined spaces, although I have used this outside. I did use this at the job I just told you about at Houston Airport, just because I needed to map some areas kind of in and around for some vents. And this was the LiDAR, and this was fantastic. I wouldn't take it too far away from the tank. We're pretty close and up, right up against it. So the LiDAR was key there in helping it stabilize. Yeah, see that. That was just a cool video that we had done up. And now let's look at pre-entry inspection. So this is a tank that had been out of service for a long time. No one had been inside for a while. They wanted to have a look, see what was inside, and see if we can actually send some people in here. Now, I showed up with the drone to go inside, have a bit of a look around. This is what I found. So as you can see, quite a lot of corrosion, quite a lot of scale up in the roofs there. You saw that previous rafter attachment there was eaten away a little bit. It's not great. Again, the nice part is just the drone was in here. So if anything happened, just the drone goes down. No human goes down. So I go through here, and then it will pop to one of the rafters as well, which is quite eaten out. It was a total of I believe it was seven or eight rafters in this tank were just completely pulled through, and they were all kind of in that one quadrant of the tank. So, oh yeah, look, you can see there a little bit of hole through on that rafter. But yeah, all in one quadrant of the tank. So yeah, that the roof in that area, not exactly stable. So they were able to come up with a plan to kind of mitigate that risk. I believe they cut some of the roof out, kind of take that away. Because I believe the end of this, the floor was actually fine, but it was just the roof and top course. And then you see that. So this raft is just completely gone, and you can see the little manway at the bottom there too. That one's roped off, and I don't know if you can see someone kind of standing outside, because we weren't allowed in. So yeah, so quite for that. And actually, the center column here isn't actually in good shape either. So come on, here's the next rafter there. Fire onto the next one here. Okay, so a lot of people ask me, how big is the drone? Like, what can we get it in? What can we look at? So again, depends on what sort of drone you're going to use for your inspection. The Ilios 3 is 18 inches wide. The Ilios 2 is 16 inches wide. The Ilios 1 is 15. There's a couple other brands out there. I just like this one. I've used it time. I've had the 1, the 2, the 3. They've all performed fantastic. I enjoy these for anything internal. So this pipe here, this is actually an overflow of a water tank, and basically no one had been in this for a long time. No one had seen, because it's just kind of an overflow tank, so no one really cared. I was doing another inspection at the time on the tank. They asked, "Hey, can you get the drone in here?" And yeah, I believe this was 30 or 36 inches across, so not an issue for the drone to get up in there. We were able to get in there, have a look, get down there. So I've been tasked before with trying to find things in pipes. There'll be another video coming up later with going in and out of externally in and out of a bunch of pipes, kind of get in, squeeze in, stuff like that. So it's definitely a great tool for that. Now, here's where this is where the mapping comes into play, where you have defects and you can map them out. So you can see on the left, we got the LiDAR. On the right, we've got the video. So this is a primary cell softener up in the oil sands. And basically they had installed these U-bolts here the year before, and they wanted to have a look at what their condition was 1 year later. And you can see this is a giant. This is like 250 feet across, giant, with a bunch of nothing in there. So it's not like someone could just kind of walk down in there, have a look. So we got the drone in there again, another pre-access inspection. So as you can see there, we're able to kind of map where this is. So here's the top-down view here. You're able to see exactly where those U-bolts are around the primary cell softener. So, and then if we go back even further, so we come back to the side view here. So this side view here, you can see where at the bottom where the manway is, where we enter. So we can set that as 0 degrees. We can also set that at whatever degree you need for the mapping. But let's say the manway is 0 degrees. That's what it is in the manufacturer's drawing. So when we get up top to look for those bolts that are damaged, we know exactly where it is. We can, organize some rope access to come down, fix those in just that area. That way they're not having to go down for each individual bolt and check it. This whole thing took, I believe I did two flights around this entire tank. So, roughly 20 minutes, and was able to determine exactly where these issues were and report that back to the client. And they were in a shutdown at the time. So they had guys on site ready to go to get this fixed. Yeah, so there's another on there. So this one's not quite going, but it's pretty close. And actually it is gone. So it's on top there. But yeah, so they found out they had to fix these right there and then, instead of waiting another year, because they were going to take it down a year later to do proper maintenance on it. So they did have to just fix these few this year to make sure. Okay, here's the other thing I was talking about with looking at piping. This is piping in a warehouse. So the next video will be of a HOSIG, that's what I was at this site to originally do. But because I was on site and, they asked me to come have a look at these pipe supports. This is a power plant, and they had a shutdown at the time. We're looking at the HOSIG, and they had companies here their whole job for the shutdown was to check all these supports. So they were going through it, but it was, they were getting delayed just with other issues. And because I was on site, I was able to be like, hey, let me come in, we'll get some video. We're able to get the map too of exactly where all these pipe supports were, what the conditions in. So now when they look at this again in 2 years, that's generally what they do at this site. It's 2 years. I've looked at that HOSIG 3 or 4 times now. But at this site here, so in 2 years' time, they know exactly where they need to go to fix these issues. They actually did have to fix that little bit of insulation because they were losing a lot of heat. They didn't know that was up there because it's just right up in the top of the warehouse there. And we want to check the support here as well, make sure all of these are still good to go. And then the nice part about the LiDAR is it actually helps you get out of areas where you can't see. I am way off in the distance here, and I'm kind of looking through. I can see the drone in the distance. It's got the lights. It's coming back at me, but it's like I still see it, but trying to get in and around all these pipes and like that is a bit of an issue. So it is nice on the control. You kind of open up that LiDAR and kind of have a look and kind of get round in, up, over. You see that bit of a mess. This was just one area. We did a ton of areas like this, and we're able to get that accomplished pretty quickly. So next one here. So all right, another fun one here with the LiDAR. So this is a HOSIG or a HRSG that found at power plants a lot. It's just a big boiler, pretty much. but it's sectioned off into a lot of sections, basically, and very tight squeeze to get in and out. So another great application for the drone here. This is also, I believe, about 100 feet in the air, roughly. Yeah, this drone is up. You can see where the drone is on the left hand side here, where it's up top there. And then here's a top down view of where we're at as well. So not only can we look at the side view of where we are, we can look at the top view as well, kind of see where we are there. And you can see, well, like some issues there. They weren't super concerned with this area. Um, they actually had some rope access kind of ready to go in this area. Uh, what was that here? Check that. They had some rope access ready to go. So in this area, and then kind of came in, like not great this area, but they said they could leave it for another 2 years. They're running out of time on the shutdown, so I was able to kind of tell them, like, show them the video. Here it is. They can look at it again in 2 years. Like, so when we go up again, we'll have a look. We'll look at the exact same area because we have the map. We'll map it again in 2 years, and get a look at the deterioration that's occurred here. So they did actually end up leaving this. They took the ropes out, and they actually, on this the next section that we go to, they actually had to use the time they were going to spend in this section in the next section, which they was not planning on spending any time. They thought this section was going to be good to go. Turns out it was not. As you see here, as we come up here, there are some rips here in this seal. So, and again, this is kind of where some heat will escape. So they want to make sure that these are all in really good condition. And as you see, just, little rips here and there they weren't too concerned about, but then in a second we'll see a couple big ones that they really get in and fix, like right here, had to get in and fix that. So again, great application for the drone. Planning, uh, best laid plans sometimes have to change. They weren't expecting to have to go into here. They're expecting to spend most of the time in the other section fixing the top there. They had to change, and we're able to do that on the fly with them. I had a guy with me as I'm doing this, looking at the screen as we're going through. So he was able to make the call right away and get answers. Whereas instead, with rope access, although they'll be able to tell you right away, it's just going to take more time for them to set up and get down and have a look. So this is in the stack area of the Hersig. So in this area here, they generally can look from the top down. They'll get a crane. They'll have a look from the top down, but they won't actually look from the bottom up. So I just want to get back to this one little section right here. So if I pause it right there, so you can see there is a little gap up there just above that ring, a little gap there. They can't actually see that from the top down when they have the crane or anything over looking down and in. You can't see that. You can only see that from the bottom up. The only way to see it from the bottom up is with the drone. You're unable to get an AWP or anything into this stack. Again, your only option is kind of rope access in here. So again, able to show them that. It wasn't the end of the world. I don't know if they fixed it or not. I'd left at that point. Okay, now we've gone from kind of the internal inspection stuff. Now I want to move on to UT. Now, this is fairly new. There's been a lot of companies trying to develop a good UT drone for a long time. And finally, in the last kind of year or two, I'm satisfied with how it's coming along. This was a cool project because we had two of us there. So obviously, one of us is going to do the UT readings. The other is going to fly and film it. So here is this is the Ilias 3. So this is what was doing all those other inspections here. Got the UT probe for it. And as you can see, it kind of pops in there with just taking readings of the rafters there. It does show the your sound and everything on the screen on your running controller, so you do know when you are getting good signal and when you're not, and when you need to redo an area. Uh, the other nice part is too, this is all mapped. So wherever these readings are taken, just hit a little POI and we get an XYZ coordinate of exactly where this UT reading was taken. The downside to the UT readings here is it is spot UT, as you can see. You may miss you may miss a like a pit or something in behind that you would normally get with a crawler or like an AUT unit. But this is how you get UT readings in places you can't get that crawler or the AUT unit in. Uh, you know, anywhere above, say, a wind girder, or in areas where you can't get a human into. Uh, the You see here with the surface isn't great. Right here. So actually, this is a good example of you see the signal here on the screen of what you get. So you know what you've got before you leave, and you can stay on that spot as long as you need to get that good reading. These do have cleaning tools. I mean, the other UT drones as well. So you get SkyGauge, Flyer, Vestec. They all have little buffing wheels on their drones, but just with power, so you're not getting through thick scale. Like it's good for a little bit of rust dust. I haven't seen one that has really been able, like that first tank we looked at. There's no drone really getting that buffed out. It's just battery constraints, power constraints. You're not going to be able to get enough power to that. Like I've been on scaffolding and trying to get scale off like that with a grinder, and it's just not really going anywhere. So it's you still do need good surface, and unfortunately in areas sometimes you can't get good surface, so you got to deal with what you can deal with. And again, if you do see areas where you may want to have a look, then we can go up with some rope access or get an AWP in there, get some scaffold up there. But this is just a great screening tool to look at those areas there. Okay, so moving on here, this next one here, this is actually only last month I did this, another kind of cool project. I know a lot of people on this call that mostly dealing with oil and gas stuff, but this is an oil and gas site, but they have clay silos, and these are concrete, and they're from the 80s, and they were having some issues with them. So see here right off the bat there, this is two silos side by side, and cracking right in between them. Just above this here, you can kind of see where the that sheet metal is. Inside, they walk through there, and that's a walkway inside there. So right away, I was able to tell them, don't walk through there until you get this fixed. And so how this occurs is you see the rebar in there. What happens is there'll be a little bit of cracking or something like that, and some moisture will get in there, and some rust will get onto that rebar, and then that rust expands, and that's steel versus concrete. Steel's going to win. This is the other side of that silo. So both sides where that walkway is going through, there's cracking in both of them. So again, right away, I was able to tell them like, hey, look, there's nothing there. Oh, sorry, you can't be walking there. Now, here's a little bit of an example of some of that really cracking. This is kind of the start of it. Like you don't want to get too much moisture or anything in these. That's how you get to that spalling. That's how something like this occurs. It gets that moisture gets into that concrete there, and causes that rust, and that rust expands there. This is actually this now becomes an overhead hazard too. So not just the drone being up there is the overhead hazard. This concrete is the overhead hazard. Like as I was there on site, a couple pieces fall, and like this is coming. Like I think this this spot particularly here was 13 meters high, where this is, but these silos are 160 feet high. And, as you mentioned earlier, that piece from top there, that's fallen off, that's hit the ground. So if you're standing underneath that that falls 160 feet, that's like a hard hat's probably not going to do a whole lot. You don't want to be around that. You want to make sure that you're mitigating that risk and keeping that fixed as soon as you can. So another thing that I know, a lot of the larger oil and gas companies, they don't just have oil and gas, they have other things to look at as well. Now, a preface to this next one here. This was the same site. We're out in Georgia. I don't know if anybody remembers in Florida and Georgia last month, they had a big cold snap, some snow came through, snow and ice. The area I was in hadn't had snow since 2017, I believe. So everyone freaked out. No one was driving, no one was doing anything. And more importantly, they weren't able to transfer the product that they needed to. And you'll see why. So here's the overview of the tank farm. See, I took a bunch of overviews for the company just because there are no overviews of snow at this site or anywhere in this state previously. So we got that there. With the issues, we were at around like right at that freezing level. So they got the snow covered the roofs, and then during the day, that snow would melt and then create icicles off the side of the tank. Now, the issue with that is you have that overhead hazard. And now what happens if that overhead hazard is right where you need to go to swing your piping to get the product out of your tank or swing the product into your tank? You don't want to go in there and risk a bump on the head or even your life to swing some product. You can see here, even accessing these stairs, it's just so icy on the side of that tank. And then we'll switch to the infrared here. So this was a big help for me on this job because I was able to get some overviews of the site, look at these dark purple spots. You can see right here, these dark purple spots on the side of the tank here, that is ice. And as you can see at the bottom, that is right over where the operators needed to go to swing those lines. So obviously they were not able to swing the lines until they're able to get this, able to get the ice melted. Nice what was, it was Georgia, melted in like 2 days. But that's still 2 days of them not being able to transfer product. Now, I was lucky enough as I was doing this. So coming up here, you'll see right where that line is, there's some ice there. I accidentally got some ice falling coming up here. So you'll see as I turn the drone, keep looking right where that line is, you'll see that ice move. Now imagine that falling on top of your head as you're trying to swing a line. And again, we don't want to put people in that situation. That's why we're here with the drone to make sure that people aren't in danger. And just in infrared because it's a cool shot. So you see there the ice falling away. The other thing I was able to do for these guys, so just because they weren't able to swing from that particular tank doesn't mean they can't swing from other tanks. So I was able to map out safe routes for them because wherever the sun was shining on those tanks, they were clear, they were good to go. There's no ice on those sides. So I was able to map areas for them to go and get a clear path so they weren't in danger there. Time here. So what we're going to do is I'm going to switch back to the slide, and then we're going to talk a bit more about LiDAR and photogrammetry and that fun stuff. So it's going to pop through here some images here. Actually, here's a good example of what you see on the actual drone screen for that UT. So let's get back to there. This is kind of what it looks like. Get that there. So this is what you see in real time on your screen on the thing. So you know, you can see in the right-hand corner, bottom right-hand corner where you are, and you get good reading right there. So let's talk a bit more about mapping and monitoring and LiDAR photogrammetry. That has been a topic here that I've been dealing with a lot over the last year. This with drones and just the ability to access, and the cameras are getting better, the LiDAR is getting better. They're not as good as like a land-based 3D scanner yet, but it's getting close. And for things that you don't need, millimeter accuracy on, the drone can help, gets everything done a lot faster. So again, you can calculate volumes, stockpiles, trenches, tank berms. I'll focus a little bit on tank berms because that's going to be important here. Again, eliminate the need for workers to access potentially hazardous areas. This actually all came up in a conversation I had where the owner was upset that the surveying company was walking up his pet coke piles and putting their GPS locators into the pet coke piles. So they saw that as a hazard, them kind of being sucked in. So, go out with the drone, get the get the volume of that pile so people aren't climbing up and getting hurt. Especially with the drone here, you can increase the measurement intervals. Do them once a month. It only takes a couple hours to get the data, and then you can generally run them overnight. They're getting better with the software. There's a bunch of different ones where you can they just like upload it to online and they can process it at a different server, so you're not having to run it off a laptop, which can sometimes be a limiting factor too. The other thing that's now becoming big as well is creating digital twins of your site. So using combination of photogrammetry and LiDAR, you can, and even just a land-based 3D scanner, you can also do this too, is creating digital twins. So, you've got people in offices, say across the country, who decision makers of a site that is, in a completely different state across the other side of the country. And, it helps the decision makers, the guys paying the bills, to see the actual site, to see what you're up against. And, creating a digital twin of your site, similar, probably take, depending how big the site is, but it is just a, couple drone flights over, a lot of photos, and you can get a good digital twin of that site. And I will just show a quick example of something like that. So this is actually the silos we just looked at. So this is just using photogrammetry here to create a bit of a model for these guys, so we can kind of look at, where the issues are, and get it from kind of all different angles here. I did this in Pix 4D, so you can actually just kind of rotate around, kind of look and see where your issues are, kind of put them out here, map them out. So then the company that is coming to do the repairs will know exactly where to go. All right, now let's jump back up to photogrammetry now. So some of the differences between photogrammetry and LiDAR. With photogrammetry, as the name suggests, we're going to collect hundreds or thousands of images. The more images doesn't necessarily mean the better. It helps, but there is a point of diminishing returns. So you want to get kind of like a 70% overlap of your images, and that will give you fairly accurate. Anything kind of higher than that, you're not really getting that return on your time. And it can, in my experience, take up most of the battery if you're trying to go 90% to get that overlap. The best time to do a photogrammetry survey is right at noon. You want that sun shining straight down. You want minimal shadows. Cloud cover can be an issue, and not the end of the world. But if you want to set up for success. So the sun kind of right above makes it a lot better. It's it's quick. The drone flight is quicker and it is quicker to process than LiDAR. And so 50 to 100 points per square meter actually is like plus minus 2 to 5% for volumes. Um, that way, I like to do it as a percentage volume just because the bigger the area, the kind of, yeah, the not the more inaccurate it's going to be, but that 2% means a lot more it's a lot more volume in a larger area than small area, obviously. Um, and then for like a plus or minus millimeters, inches, it really comes down to your camera, really comes down to your conditions. Um, you know, I don't even really want to put a number on it because it really varies like every time. And it even comes down to just having a mechanical shutter on your drone camera. Like that makes a big difference too. Now, LiDAR, so detection and ranging. So as you saw, those models I had earlier on the internal drone flights, those are all LiDAR models. So if you imagine it just that puck that's out the back of that Helios there, it spins up, gets 360 all the way around. You can attach similar pucks to like a DJI M300 Helix, I believe that's a good one. And but anyway, they can attach to not every drone, but most larger drones can take these LiDAR payloads. Um, and so yeah, emits laser pulses, measure time. I thought this is good for those environments where you have a lot of cloud cover. If you have to do it, if you have to do it inside and there is no light, photogrammetry doesn't work that well inside. So you do want to use the Helios or something similar to get those measurements inside where it's dark. Also at night, um, say you're doing it near an airport and you can't fly during the day. The FAA won't give you options to do the photogrammetry during the day. You may have to come back at night and do LiDAR. You know, airports will have like a time, like maybe 2 o'clock in the morning where they aren't flying out. That they'll give you time to go and do that. So again, that's where you're going to have to use the LiDAR. It's less efficient but more accurate. Um, so for example, this one here, it's easier for me to put plus minus on for millimeters and stuff just because uh, I'm far used to it with 3D scanning, everything like that. But again, comes down to what puck you're using, what and your setup, and how fast you're flying by everything. You can't fly too fast by things. You can't fly too slow. It will saturate that area and will actually lead to a lot more noise. So you do need to, uh, you know, go the optimum speed. A lot of pucks will tell you how fast you should be going past things. So your accuracy for volumes plus minus 1%. For a lot of LiDARs, you can get that down to, for measurements, plus minus half an inch. That Helios 3 that I was using earlier, that puck I had on it was plus minus 1 inch, roughly, I could get for accuracy. But with the bigger payloads like the MMS ones uh, that mounts on the M300s, like they're down to less than half an inch. They're very accurate. So here's an example of like flight plan that you do this is both for LiDAR and for photogrammetry. So you set this up and you want to automate this too. You don't want to do this freehand because as I said earlier, you want to make sure that your photo is being taken in the right places for photogrammetry. And you also want to make sure you're not flying too fast for LiDAR. So either case, you want to make sure that you use an automated plot for that to ensure that your speeds and everything are there. That doesn't mean you can go and have a coffee in the truck. You do still have to watch it. You do still have to make sure that you are you're looking at it. It does have to remain within visual line of sight. Just in case something happens in that time, you have a unexpected helicopter come into the area, anything like that, you have to bring that drone down right away. So you need to be prepared. So we've covered kind of the volumes there. So here's a nice example of using LiDAR for a berm analysis. So these are all the tanks here in the middle. You can see the whited out there. And I've set this so blue is low, red is high. That way you can kind of see, where the white spots are in the top left here, that's water. The LiDAR can't penetrate water, so you end up with blank spots. But as you can see, the drains are actually in that area. So I mean, the berm is draining the correct way, so that's nice. It's an example there. And then here's the calculation for that. So here's kind of the model. So you're able to calculate the gross berm volume, and then you want to take out, you know, the tanks, and then you want that want this berm to be 110% of your largest tank. And you can kind of net that out there. Now, I've done a lot of these with like land-based 3D, done some with LiDAR too. What I've found is the LiDAR is far more efficient, far quicker, but less accurate, obviously. Now, not a huge deal if you're just going to fly over it like this whole berm here. I think for the drone, this takes an hour to fly over. To 3D scan this one out, like it's 2 days to land-based scan this one out. So, you can use that. You use the drone as a tool, similar to what we're using the Ilios for going into confined space. You can use that drone for an hour. Processing time's faster than a land-based 3D too. So you could have an answer pretty quick on how close you are. If you're pretty close to that 110%, then you might want to come in and do a land-based scan just to make sure that to see where you're at. If you are way over, you got tons of volume, then you can use that. You don't need to worry about coming in with a land-based scan or doing any repairs. If you come in way under, then you want to, then you'll know right away that you've got repairs. So you can know that pretty quickly as compared to, a land-based 3D scan, but the land-based 3D scan is more accurate. Example of a internal pile. So you can't do this with photogrammetry. There's no light in here. You have to do this with the drone. I know we're running real short on time here. I'm just going to quickly go over to some OGI camera stuff, just because with, emissions tracking, everything around these days. I do just want to touch on this. I think this would be important for everybody. So, OGI camera detecting hydrogen carbon gases such as methane, propane, octane. You can have handheld and drone mounted options. The handhelds are more accurate, but the drone option can get you a lot more data, a lot more area covered. Not necessarily a lot more data, but a lot more area covered in a shorter amount of time. And also too, you can set these up to, on that same path, I showed that flight plan earlier, set them up same path on a site and check it multiple times throughout the year. One of the interesting things I found with this is we did a site during the middle of summer, and track the leaks there. We're looking at some kind of, here it is. This is all kind of coming. You can see kind of the gases coming out there. Wasn't more than usual, but then winter hit and it was off the charts. And we thought it was going to be the other way around. I thought for sure it's hotter temperatures. You're going to have more gases being released because it's like above 30 degrees Celsius, to 35. So getting up around like 90 to 100 Fahrenheit. I'm thinking that there's going to be a lot more gases around. Turns out in the winter, there was more because they had to use they had to turn the heaters on. So now the heaters were giving off a lot more gas as well. So that was all contributing. And, that was just one of those things where I was like, I had a theory and it didn't work out in my favor, and now I know, and now I tell everybody about it. Here's an example of some tank emissions here. You can actually see the product line here on these as well. So that the dark spot there at the bottom there, that's your product line. Here's one here. As you can see, they're filling up this one tank. It's quite full. They've got a lot of emissions coming from it. It might be time to swing that to a different tank. swing that line to a different tank. I'm sure their high alarms went off at this point and had to move it to another tank there. But you just want to keep an eye on that. And then this is just an infrared image I took similar to there's ice images there where I was able to see this is an ethanol tank, and you can see the product line on that. I wouldn't use infrared necessarily to just get all your product heights. I mean, you get a good idea. You could flash this over a tank farm and have a good idea of what you've got. But tank aging and losing your radar is going to be what you use, what you should use to accurately track your tank volume heights. The one time this was very useful. I wasn't there, but talking to the guy who did, it was when had the hurricane in Houston, like down Deer Park. They were using drones every day, flying over those sites to check the product lines because you can tell if there's a foot missing from this, like day after day. So they were using it for that, kind of mapping out where the tanks were at, any kind of damage, stuff like that. So that's what I use this infrared for tank heights. And that is the end there. This is I'm sure Alex would kill me if I didn't put up um, all of our services, not just talk about drones and 3D all day. Uh, and here's a contact us page there as well. So what do we get for questions there, Alex?
Awesome. Well, thanks, Greg. Yeah, we've got a few minutes left here before the end of the day. We'll just get through a couple of them quickly here. I know we looked at the LiDAR capabilities for berm capacities. Obviously, pretty impressive. The ability there really is we distinguish that because you're able to screen scan for something that is significantly over or under. And that allows you to go ahead further with 3D scanning, like conventional 3D scanning, land-based units, to then start planning for the repairs. I think that that's the idea that we want to get across there is that, you're not necessarily using the LiDAR to create the exact model and use that for repair situations, but it's to basically tell you, hey, is there a problem here? Or no, hey, the berm is 10% over what it's supposed to be. No need to spend all the additional time and money doing the land-based scanning.
Yeah, exactly. And it's great for those giant berms, like out in like Cushing or something like that, where if you want to have a bit of a look, but to land-based scan those would take forever. Whereas with the drone, you're
Yeah.
probably doing that in a day, right?
Right. Yeah. Fair enough. On the reporting side of things here, we're looking at highlights videos and things like that. How quickly are we able to turn that around? I know you've been on site in a few instances and we go straight from field right into the boardroom and videos are up. So highlights videos, sending data, that kind of stuff. What do you recommend? How quickly can we get that to people depending on what they need?
So I would suggest whenever I go to a site, always just try and have a meeting right afterwards. I'll just download the footage from the drone, whichever drone I'm using. It doesn't take that long. Like maybe just give me an hour after I'm done, and I can get the footage onto my laptop. We can go to a boardroom, or we can just look at the laptop screen. The nice part with all these drones here, you can just hit like a POI button, and so you can just go straight to the issues that you saw and you can just do a quick highlights of what you saw, especially for stuff that and during a turnaround where everyone needs answers right away and they need to be planning for night shift in like a couple hours. You want to get that information to them right away. Um, for reporting, it just depends on how busy you are, but you just talk about that with the client beforehand. If they need it right away, then just block off time afterwards to say, hey, I'm gonna delay the next job here a day because I need to get this report. So just you're gonna have that conversation before you go to site on your expectations of report turnaround and what they need. But I always suggest just doing a little bit of video presentation afterwards. Generally, as soon as someone hears there's a drone on site, everyone on that site is generally in my pocket having a look anyway. But it is good to just do a quick show and tell afterwards.
There's a question here about the UT drones. We looked a little bit at the capability for mapping in real time in space with LiDAR capabilities there. What this person wants to know is, can the previous CML or TML locations be found using the UT drones, or do new locations need to be established with the drone mapping coordinates? I think maybe it's kind of a two-part question. One, could they give you an existing site map, maybe a 3D model that you can implement into the current a LiDAR understanding of the unit, or do you just need to basically know where those areas are, click a POI for them, and develop a new model, which you can replicate afterwards with the drone, however many times you want?
Okay, yeah, that's a good question. So, first off, externally, if they're marked, then you can just use the camera to find them. I'm just trying to find, was it? Oh, I don't have a shot here with it on that. Anyway, okay. So, anyway, but for example, using this here, there is an XYZ coordinate at the bottom. When I'm taking, if you give me the XYZ coordinates of your old CML areas, I'll set the drone to whatever 0 degrees is at the bottom, and I can use that in real time to go to that area and hit that with UT. It may not be like bang on like to the millimeter, but it's gonna be right there. It's gonna be about the same as someone with a hand. You know, if that circle is 2 inches in diameter, I'm gonna hit it inside that circle. That's no problem. It's gonna be the same as if I'm doing it with my hand. But you can get to those areas on the inside, no problem, as long as I know where they are beforehand. If I have an XYZ of them, if you just kind of tell me like, hey, it's about here, it's about there, then yeah, it's going to be the same as a person going up because they also not going to know where it is either. Um, I'll take the drone up there, but and then if you want new CML points, then yeah, you hit a little POI, you get the coordinates, and as long as you keep setting, as long as you keep making sure your 0, 0, 0, your origin is in the same spot every time, then you can replicate that again and again.
Sounds good. One more question here to end the session. This person wants to know about the signal and how it's affected inside of metallic structures. So, what's the coverage from the RF signal, and is that affected in any way?
Uh, yeah. So depending on the environment. So for this tank, so for this PSC, this PSC tank in front of us here, I was outside, had no issue with signal whatsoever. Um, I have found issues sometimes with insulation on a tank that has, if I'm outside, as soon as that drone gets inside, it's like I have no signal at all. That the nice bit is with the Ilios, it will just, if it loses signal, it just retraces steps, comes back out. In that case, what you can do is either, you got to be right at the manway, you got to point your antennas into the tank to just get some signal into there to get it bouncing around in there. Steel is great. Concrete, not so much. Concrete will kind of absorb the signal a little bit. Steel is fantastic. You get that signal in there, it'll bounce through. Uh, then you also have the option of signal boosters if you need to. You can sit one of those you can sit one of those kind of on another. If you're in a tank and you got two manways opposite each other, you could have your controller at one manway, then you could have your signal booster at the other, kind of connect them, and then you set. You're not going to lose signal at all. But knock on wood, I haven't had too much of an issue with signal. Um, and mind you, you know when you're running low on signal, that drone starts playing up a little bit, and yeah, you'll know you want to bring that thing back pretty quick. There's nothing that'll make your heart drop more than losing signal and that drone all of a sudden kind of dropping.
Well, sounds good. Just a quick note here, lots of good comments, people coming in pretty impressed by the drone capabilities. Everyone always likes to see the videos. A note for all the viewers here, obviously, trying to optimize video quality within the Zoom conference and get that across to you is can be a little difficult sometimes. So if you do want to see some of the example videos in their high quality format so that you can actually get a feel for what we're looking at when we're doing these inspections, feel free to reach out to Greg. His info's in the chat box there. Greg, thank you very much for the presentation today, and I'm going to make a note as well. Greg is presenting with the boys over from Pemi Consulting. He'll be in April. He'll be at NISTM as well. So make sure you catch him for the Tanks 101 course. You got a chance to track him down and talk some drones there as well. And we've got one more day coming up tomorrow. I want to say thank you to all the viewers for joining us for the 5 sessions today and for the ones yesterday. And we got 3 more really good ones lined up tomorrow. So thank you, everybody. We're looking forward to seeing you again.
Yeah, so I'm also sorry, I'm also presenting at the Canadian School of Hydrocarbon Measurement coming up in March in Calgary, and also Cooper in Anaheim in California that also in March. So if you're out there, track me down. Cooper is on drones. School of Hydrocarbon Measurement is on volumetric calibration. So we covering lots of stuff. And then with the videos there, reach out. I'll also be posting them on my LinkedIn too. So just follow me on LinkedIn or follow Ranger Inspection on LinkedIn as well. And you'll be able to see those videos there too.
Awesome. Thanks
All right.
again, Greg. Thank you, everybody. Take care.